Hello, everyone. Welcome back to Software Analysis and Design. Today, we're going to look at context analysis. So that means we'll be looking at context models and its stakeholders, actually in the other way around. We're going to start with taking a quick look at the required reading that was assigned. That was the article in IEEE Software, What is a Requirements Engineer by Barbara Pech. And then we'll look at stakeholders, and then we'll take a look at context models, and then in the end, we'll have a little exercise on context models. For the reading recap, up here in the corner, as soon as I move my face out of the way, you see Professor Barbara Pech. She works at the University of Heidelberg, and she has been working in requirements engineering for a very long time. She also happened to be the second supervisor of my PhD thesis. That, however, is not why I selected that article. I just wanted to give you one little article that has just a couple of pages to get you into a good habit of reading IEEE Software. IEEE Software is a magazine that has articles written for both researchers and industry practitioners. That doesn't mean there is not also research going on in industry. Let me rephrase that. It's both for academia and practice. It's for research and daily software development. It's for all the above, for all those people. Everybody who's involved in software development is potentially a reader that we try to target with IEEE Software. And so you will find that the writing is fairly accessible compared to some research papers that are often written in language that is a little harder to understand. IEEE Software is for everybody to read. If you're in IT, if you have anything to do with software, you can read IEEE Software. And so this particular article is in the requirements engineering column, and Barbara describes how there had been a couple of years of work going on to try and get together and establish something like a certified professional for requirements engineering. There is already one successful model out there that they were trying to follow. So there is an international software testing qualification board. And that is the good example they had to work on or to work off of. And what came out of this effort is the International Requirements Engineering Board, the so-called IREB. And you can go visit their site at ireb.org/en for the English version, because it was originally established mainly by people from Germany and Switzerland. However, by now it has a fairly international board, and it is available in several languages. In their work, they have established a syllabus with the requirements engineering process and with the skills that are connected with that. Now, right now, we're in a course on software analysis and design, so requirements engineering is not our main focus. The reason why this article appears at the beginning of this course is to try and remind you what happens before we get started with the work that we're starting here, but also there is a fairly significant overlap in between those two. So I invite you, for one, to just remember the requirements engineering knowledge you have. If you don't have requirements engineering knowledge, I got something for you. I happen to also have an online course on YouTube on requirements engineering, so feel free to check that out. It is linked with exercises and assignments and the slides that I've been using throughout that course on the free open source software wiki that you can also find in the details. I'll put the link into the description of this video. And the other part is I would invite you to consider maybe becoming a certified professional for requirements engineering, because many of you who are taking this course will have the knowledge required in there. Maybe you can brush up on it a little and then get certified. It may be very useful for your CV. With that, I'm curious what you thought about the reading in comments, and then let's go ahead and jump into the content for today. First thing we'll talk about are stakeholders. You may also remember stakeholders from any course that you've taken in requirements engineering or from something you've read within requirements engineering. A stakeholder, just to recap, is a person or organization who influences a system's requirements or who is impacted by that system. So people who would typically influence a system's requirements are the project leader, the client, the requirements engineers, the software developers, the testers, the maintainers, domain experts that we may choose to talk to, but then also people who are impacted by that system. So the direct users, but also some indirect users. Say, if there is a school management system that helps kids manage homework, or that will also impact the parents significantly, or the other way around, if there is a parent-teacher conferencing tool that we may see more now that we work more remotely, then the kids will also be impacted by that in some ways. And so it is good to have the direct stakeholders, but also think about who could be indirectly affected. Also, in addition, an interest in the system does not necessarily mean an interest in project success. There could be a competitor who has the interest of you not being successful, or at least of them being more successful. But there could also be legislation, so legislative organs that impose constraints on the system, standardization organizations whose rules we're trying to follow, whose standards we're trying to adhere to, and then unions, staff associations, any kind of organization that will stand up for the rights of a particular group, or the environment, or animal rights. There are domain examples from very, very far apart domains that could be named here. Now, with that definition, how do we get to our stakeholders? How do we identify them? There are a few different approaches for identifying stakeholders. Most likely, the best way to make sure that they all have been identified is a mix or an iteration of those following four approaches. You could go in the order that they are presented in, but you could also choose a different order. The first one that we're going to start with is the phases. You are at this point familiar with the basic phases in the software engineering process. That was also a recap in our first lecture here. So you could analyze the aspects and the development phases of software systems development to find the responsible roles in each of those phases. And that approach is a pretty easy way to set up very early elicitation meetings with the most important, the rather obvious stakeholders. So it's good. Like, you can be done in 5 minutes with your stakeholder list. You just write everybody down, like, oh yeah, client, manager, requirements engineer, business analyst, software developer. I mean, you write them down in 5 minutes after you've done that for the first time. Maybe the very first time it takes you a little bit longer. But that way you can get started super quick. The obvious people have most important first scoping discussions. The difficulty is, very often we find in practice that we stop too soon. We get busy. We get busy with developing what we already know we need to be working on, and we don't necessarily invest a whole lot of time into finding other people that also may have something to say about the system and that may have super relevant context information over there, or that may be a domain expert, but because they only come to the company that we work with every 2 weeks, they just, I don't know, slid through the net when we were trying to find all the people that were relevant. So therefore, we use a couple of other approaches to make sure we find everybody who we should really be talking to. A fairly easy second step to do is go check a reference list. There is one a few slides down that you can look at. So instantiating generic reference lists of stakeholders for the concrete project context. And that will take some standard roles into account that have been included in these reference models, and that will enhance your very initial quick list of stakeholders. One simple reference model that I've used a lot in the past, and that is also in my requirements engineering course, is the so-called onion model by Ian Alexander and Suzanne Robertson, also published in IEEE software. And it has 4 concentric spheres. It has the product itself, then the system, the containing system, and the wider environment. So you get to all those direct stakeholders first, but then you also get the indirect stakeholders, and then you get the ones that don't affect the system directly, but that may affect it indirectly. So that's your second part. The third step is that you can inspect the context of the system. So you look at the business context of a system. For example, if we have a system that is trying to sell books online, then the business context is selling books online. The operational context is we have a web server, we have to deal with a database, and we have to deal with a delivery system and all those kinds of things. So you understand the difference in between the business process and then the operational and technical infrastructure that makes that possible. So that will make sure that you understand which roles are included in both of those contexts, and that makes sure that the specifics of the project under consideration are all met and special roles are considered. Because if you look at the business context, then you will find all the domain experts that otherwise you might forget to talk about. If we were to develop a financial system software, I would not be the best domain expert because finance is not my expertise. So I would need to make sure to invite all the finance expert to the table so I can learn enough about their domain to understand what the important constraints are for the software system. Number 4, last but not least, goals. So if early on in your requirements engineering, you develop a goal model to write down all your high-level goals of what you want to achieve, the high-level objectives for the system, then you can iteratively analyze and refine that and deduce the related roles. So this is important, especially for finding some passive stakeholders that don't have an active interest in issuing own goals, but whose constraints have to be adhered to. For example, legislative representatives. They will often come into a goal model by, oh, there's this objective over here to satisfy this standard or norm, and that breaks down into further sub-goals, and then we find out about the people who we need to be talking to. Good. 4 approaches, you're gonna get a lot of stakeholders together, no problem. What do we do with that now? We gotta analyze. We gotta analyze these stakeholders. So we can include developing a stakeholder model and a stakeholder matrix to get a better overview of the approach. The stakeholder model will often be, in UML, for example, a hierarchy of actors, but it could also just be any icon model where you find some illustrative representation of a particular stakeholder, and then you also make a matrix that will give you an overview of the following information. What is their motivation? So that means how much power do they have? Are they a supporter or not so much of the project? Are they a project champion? Or are they rather disinterested? Are they a passive stakeholder whom I can't take much time off because they won't be able to devote much time to this? And then what are their expectations? Like, what are their needs? What are their concerns? What are their wants? What do we expect of them? Like, what is the task that we need them to do with us, and what are the expected results? How expert are they at what they do? Like, have they just started 6 months ago, or are they an expert with 20 years of experience on their back? Where are they? What is their availability? Like, how available are they for communication and or negotiation? What is their authority level? Like, what's the level of influence? What's the impacts, or how can they enhance this? And then also, what is their relation to other stakeholders? These are the hierarchical and official relations, as well as informal friendships or rivalries. And those can often come around and bite you in the butt, because as a requirements engineer coming in from externally, you will not learn about those until much later. Like, you got to listen really well and read between the lines to find out about those things. And sometimes you still won't know. So this list is a super simplified version of a stakeholder analysis template. And a template like that can ensure that the major characteristics and needs of a stakeholder are taken into account. In the bottom left corner of the slide, you see the reference for the paper that this content comes from, that I named on the previous page, Ian Alexander and Suzanne Robertson, Understanding Project Sociology by Modeling Stakeholders. And in that article, you will also find the onion model. I apologize that the text is overlapping, but you can pause right here, rewind, and know this is what you're looking for in IEEE software. And here you see the example matrix. So I move this over here. We have classes of knowledge, like, what do these stakeholders know about? Do they know about goals? Do they know about business constraints, about technical constraints? Do they know about functionality, look and feel, usability, performance? And on the left, we have the roles, like part of the roles, from client to customer to business subject expert, future idea specialist, and so on. Technical user, potential user, sales, marketing, aesthetics, graphics, usability, safety, security, culture, very important, especially as we're moving into a global environment, legal specialists, environmental specialists, maintenance, packaging, manufacturer, and product installer. And then you see there's a name for each responsible stakeholder, but also an involvement. How involved are they going to be? How much do I need them? What time will I possibly have with them? Here's the reference again, this time without an overlap. Now, what do I do when I'm not sure what to fit a stakeholder into a matrix? Often we have several roles for a stakeholder, so which do I fit it in when I came across? Not a problem. Multi-classing, because wizards run out of spells. You will know by the end of this course a couple of my favorite movies. That's just what we're going for. So when you have a stakeholder like Gandalf, who knows how to fight and knows how to use magic, then great. You have two birds. I don't like that saying. Two butterflies caught by one net, but I don't like catching butterflies either. Never mind, running out of metaphors. So if we can get to sit down with Gandalf, we learn not only about being a wizard, but also about being a warrior. And when you have stakeholders that belong to multiple classes or to multiple roles, then that essentially makes your elicitation easier. So make sure you take advantage of those. This brings us to our first important design habit, because at the end of the day, when I have about 25 or 55 stakeholders that I need to talk to, for understanding the domain that we're working in, for understanding the context that we have, and for being able to get closer to my system analysis, then I can easily get overwhelmed with the amount of information that is coming in. For that, we need good design habits. And the first one, from the beautiful book that Marion Peter and Andre van der Hoek published a couple of years ago, it's called Software Design Decoded. It has 66 design habits that are super useful. They found out about those habits by observing very experienced and very good software developers, hundreds, thousands of them over quite a few years, and finding out what their design habits are. What are their best practices? And the first one I want to introduce you to is experts focus on the essence. So every design problem has an essence, like the core problem, the core set of considerations that must be understood and nailed in the design solution for it to solve the problem successfully. And that essence can be quite disruptive. So changes in the core can drastically alter the peripheral decisions that need to be made. Experts focus their efforts on the essence first and delay expending effort designing on the periphery. How do I translate this for you? So when you look at developing a complex system, we often are confronted with a new domain. And so we have to learn quite a bit about that domain, yes. And some stakeholders will pull you in a certain direction. Will be like, well, let's talk about the user interface. But before we can talk about a user interface, we really need to understand what is the core crux of the problem. Like, what is the most difficult thing that we're dealing with? For example, when you think about designing a traffic controller and having a traffic simulation. So say we're developing this for a driving school. We're trying to develop a driving simulator so I can practice driving at home in front of my computer and dealing with situations as they come up before I get out on the road. A lot of students would first jump on how do we do the map and what is the most important things that need to be up on the map and how do we monitor that. After working on it for a while, you may find out though that actually the most difficult part is how do I control and how do I work with the traffic lights and how do I understand where the vehicles are in position on the map. So it's more about moving objects and about having a control over them than about how to visually represent it best. So that just as a first design habit, we'll keep circling back to those because those are a couple of ground rules of thumb that I want to get really ingrained with you in this course. With that, keep the essence, and look at that first, find the essence. We're going to look into the context model. So once I have a rough idea of the people I need to talk to, I can start developing my context model of the system. And that context model, or the activity of context modeling, defines how context data are structured and maintained. The context model aims to produce a formal or semi-formal description of the context information that is present in a context-aware system. And the context is the surrounding element for a system, and the model provides the mathematical interface and a behavioral description of the surrounding environment. Whoa, pause there for a second. The context is the surrounding element for the system. Good, okay, so we have our system and we have the context around that. And then a model of that context gives us a mathematical interface and a behavioral description of the environment. So that model, as you remember from the concept lecture, will simplify, it will abstract, it will make things more general, it will leave out details. But it will give us a sufficiently detailed insight into what is going on in the context, what elements of the context are interacting with our system. So we reduce to represent only the reusable context information of the components. And the key role of the context model is thereby to simplify and introduce greater structure into the task of developing context-aware applications. And pretty much all of the applications that we develop are to some extent context-aware. Maybe not to all of the context, but to some of the context. Like even if I just have a game on my mobile, a game on my mobile phone, then there are certain things that this game will be aware of that are happening on the phone, despite the fact that it might not be aware of what else is going on in the environment outside the phone. The unified modeling language, as we use it in this course, defines the context model as the physical scope of the system being designed. And that could include the user as well as the environment and other actors. That means not only other systems are going to show up in your system context diagram, but also maybe some other actors. And the system context diagram then represents that context graphically. The system context diagram, here in its own definition, is a diagram that defines the boundary between the system or part of a system and its environment and showing the entities that interact with it. The diagram is a high-level view of a system. So this little definition already shows you the most important part that needs to show up there, the system itself and the entities that interact with it. And that diagram then is a high-level view of the system, the most high-level view that we'll be dealing with. And a little more on those system context diagrams. They show a system as a whole and the inputs and outputs from and to external factors. One definition, according to Kosyakov and Sweet from 2011, is that system context diagrams represent all external entities that may interact with a system. Such a diagram pictures the system at the center with no detail of its interior structure, surrounded by all its interacting systems, environments, and activities. The objective of the system context diagram is to focus attention on external factors and events that should be considered in developing a complete set of system requirements and constraints. So this definition has, again, representing all the external entities that may interact. We don't know the details of the interior structure of the system, which means that your system itself shows up as a black box in the center of the diagram. And then it's surrounded by interacting system, environments, and other activities. So we can focus our attention not on the black box in this case, but we look at where is the system boundary of the black box, like what are the things that the system is talking to on the outside. They're usually used very early in projects to get an agreement on the scope under investigation, like the scope of what we're looking at. And they are typically included in a requirements document. These diagrams must be read by all project stakeholders and should thus be written in plain language. So we're not going to use all the fancy technical terms. We're going to use very simple terminology so that all the stakeholders can understand all the items within the document. That is not to say your stakeholders are not smart enough or not educated. That just means that they are stakeholders from very different educational contexts. There may be some very highly qualified software engineers, and there may be some very highly qualified financial people. They have a subset of common business language, but not all of the language that they work with every day is going to overlap. So we got to make sure that we don't get too specific, but we hold it on a level where both sides, the domain experts and the software experts, can talk with each other. And here is the example. Ta-da! So here we have the NOPS data exploitation, and you see the system in the very center. We know nothing else, nothing other than the name about the system, but we're getting to learn a whole lot about the environment of the system. So we have several sets of customers that we are in contact with, and you see that being in contact with has different forms. We have several arrows going in and out. So there are some NOAA unique products that go towards the customer. There are some tailored products that go towards the customer. And then the customer in return can send in service requests and can receive service responses in return to that. Then further on the right, we see a comprehensive large array stewardship system that our system supports in two ways, with the unique products and with the system components. And then there are reports that go out towards the management. The management apparently does not directly manipulate the system, therefore there is an arrow in only one direction. To make sure that when you do your system context diagrams or your your context models, that you always acknowledge the direction in which a relation is going. And then on the left side, we see the integrated program office that also receives requests and requirements. And then we have the product developers. The product developers, they receive the operational standards by the system and they feed the system with the algorithms that they have developed. And then we see a mission management center that provides the instrument status as well as the satellite status to the system, but it does not receive any information from the system. So again, one-way communication, we're just getting inputs from that system. And last but not least, we have an interface data processing segment that also gives input to the system. So this is one example for a system context diagram or a context model. You can find many other examples out there. I figured I would keep this one short. If you want more examples, let me know. Now the elements, let's speak about the elements for a moment. Context diagrams can be developed with the use of two types of building blocks. There are entities, also called actors, and they are labeled boxes. One of them is in the very center representing the system, which is right here, the round system in the middle for the data exploitation. And around it, there are multiple boxes for each external actor. Those were all the green boxes on the outside. Some of them were users, management, and some of them were other systems that we talked to or that we received input from. And then there were relationships. So there are labeled lines in between each of the entities outside and the system in the middle. And those relationships are directed. So it's important to put the direction on those. And one simple example would be customer places order. So customer places order would be customer on the outside, green box, relation towards the center to the system, and the relationship says places order, and then the system can process the order. Context diagrams can also use different drawing types to use to represent those external entities. They don't have to be green boxes. They can also use ovals, they can use stick figures, you could even use little pictures or little clip arts, any other representation that conveys meaning. What's the advantage? Well, if you start with just boxes, it's super simple, it's quick, and if you just talk amongst a couple of engineers in a team, maybe that's the easiest way. If you know this goes into your requirements document, which it usually will, or into an early design specification, then that will also be seen by a lot of other types of stakeholders. So you may consider using stick figures, pictures, clip art, just to make graphically a little easier to understand what these entities are that are in conversation with your system or in relation with your system. I'm a friend of colorful and pictorial context diagram elements. Not everybody is. It's a personal choice. One of the many design choices you'll have to make. So design not only applies to the software design, but then also to how do you design your individual diagrams. An alternative, if you do like it really colorful, is the so-called business model canvas. So because the best system context diagrams are used to display how a system interoperates at a very high level, or how systems operate and interact logically, there is not only one best way how to do that. The system context diagrams that we saw in the previous slides, they are best for transporting things from an engineering-y point of view. So for how does the infrastructure work? How do the technical systems communicate with each other? So that may be very useful for embedded systems and for hybrid systems. There is very different perspectives that we can take on. And you remember George E.P. Box, who said, essentially all models are wrong, but some of them are useful. And yes, that system context diagram is like super abstract, and there's just a couple of boxes and like one bubble in the middle, that's your system. So it's very abstract and very minimalistic. And it may still be useful to convey what is the general setup that we have here. Now, depending on the type of system that I have, if this is a new business that I'm trying to support digitally in some kind of way, and we're seeing that a lot in the IT business now, that all types of businesses are trying to go digital, then maybe a different type of model is more useful. And one of the alternatives here is a business model canvas, which is a strategic management template for developing new or documenting existing business models. So business models, that means we're not talking about the web server or the database where something is. We're talking about goods being delivered to a customer and orders being dealt with without or abstracting from the technical infrastructure that makes that possible. So it's a visual chart that has elements that describe a firm's value proposition, infrastructure, customers, and finances. And it can assist companies in aligning their activities by illustrating potential trade-offs. We're not going to work extensively with the business model canvas in this course because it's not the thing we will most rely on. This would take us further into business operations, business processes, into business analysis, but I want to show you at least one example. So here we see the business model canvas of Kelly's Lemonade Stand. So we have key partners on the left, which are the municipalities, because somebody has to allow for that lemonade stand to be placed. We have the key activities of making lemonade, marketing, and selling lemonade. We have key resources, which are the ingredients for the lemonade, the salespeople, the booth, and the equipment. And then the value proposition in the middle is cold, tasty, natural lemonade on the go. Wonderful. That's what we want, especially on a hot day. On other days, never mind. No sidetracking. What are the relationships that matter most for this business? If we're talking about a little lemonade stand somewhere out in the street, as this little icon seems to indicate up on the corner, then it's mainly personal relationships. If I walk past Kelly every day and she has a happy smile, I will sure buy lots of lemonade. If this is a super busy street and Kelly always has a not so happy face on, maybe I'll buy a lemonade one day and see if it makes her happy, and maybe I'll just not even notice it that much because I'm busy with things that are going on in my head. No idea. But it's about personal relationships. If you think about like the little corner store where you sometimes go buy things, you kind of do develop a relationship with a person that gives you the goods that you came for. Whether it's like this friendly older gentleman, or whether it's this young happy girl, or whether it's this just really warm motherly figure in her 40s or 50s, it doesn't matter. It becomes personal on a level if we allow it to. And for those little businesses, that makes a very big difference in their sales. So the channels by which they can sell are the direct booth sale, and then also via kellyslemonade.com. It appears they have a delivery service. And the customer segment are park visitors. So this lemonade stand appears to be in a park. On the bottom, you find the financials. You see on the left the cost structure. We have costs coming in for the ingredients, for the equipment, for salaries and commission, and for flyers. And on the right-hand side, you see the revenue streams, which are lemonade sales and tips. There we go, business model canvas. If you would like to learn more about this, there is a great book by Leon Osterwalder that details the business model canvas, and I've used it a lot in the past, also with projects that students have worked on, as well as I've seen a startup company in California take this idea for developing business plans online and have people find partners for business plans on that platform. Little shout out to partner in California. Anyways, if you ever think about running your own business, this is a very helpful tool to get started with. And if somebody comes to you with an idea for a system, for a software system they may need from you, and during your conversation, you kind of figure out that they are not quite sure yet about all the elements of their business model and how they play together, maybe you can work with it as well. With that, back to the design habit. So I'm showing you all these different things that will be useful, the system context diagram and the business model canvas. And then I have to pull you back into here, into the really small space where I tell you, hey, you know what? The most important part is that you figure out what is the essence, what is the core problem of the system you're trying to design, because that's where you'll have to do the most thinking work. So you focus all your effort on the essence first, like what's the most difficult part of this problem, and then you can work on the periphery as well. This is where we get to the part where you are active. Yay! So we're going to draft a context model. You're going to draft a context model. For the system context model, we will use a system context diagram, so like that UML diagram that you started working with. So I invite you now to take a piece of paper and sketch a context model for an amusement park. If you are in Sweden, take Liseberg in Göteborg. It's a fairly well-known one. It's the biggest one in Sweden as far as I know. If you're not from Sweden and you've never even heard of Liseberg, maybe you try Disneyland, maybe you try Universal Studios, or do any other famous park or non-famous park that you know of and work on that. So you put your system in the middle, and then you put all the entities that interact with your system on the outside. What exactly is your system for an amusement park? Get clear on that and limit that. One suggestion that you can use as a starting point is you can work with the entrance system, like the system that sells the tickets for the park, for the different rides, all-day tickets, tickets just for rides, all the different types of tickets, weekend specials for kids, for seniors. So think about who all the actors are that you may have to interact here with. Think about which other systems your system has to be able to interact with. And also think about which direction the information flow goes. Is your system, your ticket sales system, getting input from another system or from an actor? Or is your system producing output for another system or for another actor, for another entity? You will surely be able to find at least 10 entities that interact with the system. And no, I'm not giving you the answer right now, because otherwise you would just keep that video rolling instead of actually doing the exercise. You'll get that later. So summarizing, we started with the required reading, which was the International Requirements Engineering Board and their syllabus, a short article presented by Barbara Pech in IEEE Software. We talked about stakeholders, where to find them, what they're useful for. We talked about the context modeling. I'm sorry, there's one element here in this bullet point list that shouldn't be there. Domain model we'll actually talk about 3 lectures later. So we talked about the context model, the system context diagram. We also talked about the business model canvas, and we talked about the design habit of focusing on the essence. And the exercise that I very much encourage you to do is drafting a context model. While I will not be the one standing behind you looking over your shoulder saying, you gotta do that exercise, really, I will tell you right now that you will get so much more out of watching these lectures and out of dedicating yourself to this content if you just try it out yourself. Please do it. Leave your questions, leave your comments, leave your suggestions, and have fun with that little exercise. I'll see you soon. Thank you.